before starting today's session, do you have any doubts?
No, Venkat.
You, Ravali?
No, Venkat.
Okay. Okay, today we'll start with parallelism. So, Abinitio supports three types of the parallelisms. One is component parallelism, pipeline parallelism, and data parallelism. Okay. So, why do we require parallelism?
To make the dev process more faster, you will go for the parallelisms.
Pardon?
No, make the process more faster.
Okay.
If you go for the serial processing, it will take the record by record, so it will take more time.
Okay. So already, then we might have covered some concepts on the parallelism, right?
Yeah.
So which components so far, whatever the components we discussed, which components provides parallelism?
Partition components will provide parallelism.
Okay, and what kind of the parallelism it supports?
I think it is data parallelism.
Yes, absolutely right. Okay, yeah. So for whatever we discussed, it's clear for you guys, and I'll come up with the component parallelism. And coming to the component parallelism, so this parallelism occurs when program components execute simultaneously on different branches of the graph. So when program components are executing simultaneously on different branches of the graph is called as a component parallelism. There are two components, program components. I have two different flows in the graph. The data is reading from the file from the first component, and from the second component also reading the data from the another file. So then these two components are running together simultaneously. There is no dependency between this another on the other component. So whenever you run the graph, and these two should be like on the 0th phase, then in such a case these two components will be running simultaneously on different branches of the graph. So whenever any of the graph which is running like this, the program components on different branches of the graph is called as a component parallelism. So this can be divided like this, using multiple data sets and then two program components connected and the flow carries together. Or else, whenever you are using a partition component, let's say like partition by expression you have used, or any of the other component also. So instead of making the flow into multi-way, we can even divide the flow. If you are using like a partition by expression, salaries less than 10,000 will comes under one flow and greater than 10,000 will come another flow. So like that also we can make it. Then in such a case, after the partition component, again the flows are becoming parallelly, and that makes the program components to run on different branches of the graph. So these are the two program components again running on different branches of the graph. So here the branches are dividing. This is another branch and this is another branch. So these two programs run together again. So in any of the graph, whenever you are seeing like this, the flows on different branches within the same phase, then we can say that it's a component parallelism. And coming to the pipeline parallelism, so by the name itself, what you can say, what is a pipeline? Say you're reading the data from the file and multiple different components. You have it. Let's say reformat, rollup, and then some other components. So coming to the pipeline parallelism, when multiple program components are running on the same branch of a graph, then we can say it as a pipeline parallelism. Pipeline in the sense, so this has to run, then it will be running it. Then it should run. So one after the other simultaneously on the same branch of the graph, then it is called as a pipeline parallelism. So what do you mean? So let's say here I have 10 records. So from the, this is also an input file component. It has to read the data from the file which is landed on the disk. So first record it will be reading and sending to the this component. Let's say reformat and rollup, we are using it. So the record comes to the reformat, it has to process, and then the record will be going to the roll up, the first record. So once the first record has been processed by the reformat component and sending to the roll up component, this will be ideal? No. It will be processing the second record. It reads the second record from the file and process it. So if you can see parallelly, the roll-up component will be working on the first record and this will be working on the second record. So once the reformat processes second record, it sends the record to the roll-up. So now the roll-up will be processing on the second record, and once it sends the record from the output port to the roll-up, the reformat reads the third input record from the file, and so far it will be working. So in such a case, don't you feel these two components are working simultaneously on the same branch? Yes. So in such a case, this kind of the parallelism is called as pipeline parallelism. Clear? What is a component parallelism and what is a pipeline parallelism?
Yeah. Venkat, for example, if there is any sort component,
Okay.
then it will hold the data, right?
Yeah. Next point is that only.
First, it will hold. Yeah.
So far it is clear?
Yeah.
Okay. So sort is a component which breaks a pipeline parallelism. So let's say you have the input file and you have to sort the data and then send it to the roll-up component. Then in such a case, till sorting of the whole data, the data will not be coming from the output port to the next component. So whenever you are using any of the sort component in your graph, then one of the parallelism that breaks is a pipeline parallelism. And along with the sort component, the components which are having in-memory concept will also break the pipeline parallelism. Is it clear?
Yeah. So join will break, right? If you use in memory.
Yes, yeah.
Okay.
And coming to the data
Any
parallel,
other component?
pardon?
Any other component?
These are the two concepts. One is sort and any component.
No, no, no.
Yeah.
Is there any other component which will break the pipeline parallelism except sort and join?
Roll up, scan will also accept, right?
Oh,
Sorted input parameter.
okay, okay.
And we can even set in memory also for the processing.
Okay.
And coming to the data parallelism, so I have an unsorted file. This is very huge file, unsorted file. So what I want is again a serial file with sorted data. So what is the process you follow? So for whatever you know, based on that, what are the components you will build? So this is an unsorted file, unsorted serial file. And I want the output as sorted serial file. But this is very huge file. So what are the components you will build it to make this sorted file?
Mhm.
Can you guys think what all components we can use it to achieve this unsorted to the sorted serial file?
I think we can go for the partition first and then sort and then departition. Right.
Yes. So whenever we have the huge files, we have to use a partition components. So whenever we are expecting the sorted file, definitely on one of the key we have to expect it. Then in such a case, better you use partition by key component and distribute all the records to one partition and then sort it. So, and once the data has been distributed, we have to do sort. So once the sorting has been applied and I want to make it to the serial file, then in such a case again I have to use a deportation component. So here partition component and a sort component which needs a sort on the partitions and deportation component. So how the data parallelism is occurring? Let's say I'm running it in two-way MFS file system. So whenever you use a partition component, the data will be distributed across multiple partitions, and whatever the components you're running it after the partition component, you have to run on those partitions. So the graph looks like this at high level. This is my graph, but internally how does it looks and how does it behaves is, So internally your graph will be running like this. So once the data comes from the serial file, after using the partition component, the data will be distributed across two different partitions, partition 0 and partition 1 if it is a two-way MFS file system. So to sort the data on these two files, two data partition files, the sort component has to work on two of the layouts where the files have been created. So this all we discussed in the partition components. This data partition files can be created in the same system, or one of the partition file could be created in one system and other the partition file should be created on the another system. So you can take it as the control file and both the data partition files should be laid on the same system, or else the control file on one system and data partitions on the second system, or else the control file on the one system and data partition 0 is on another system, system 2, and data partition 1 is on system 3. In such a case also you can treat it as. Then in such a case, let's take it the third case where the control file in system 1, data partition 0 in system 2, and data partition 1 on system 3. Then the sort component has to work on system 2 and this component of the sort has to work on system 3. So what is the layout? Means where the component is running, it has to be defined. Otherwise, how does the component can I know where it has to run? So we have to specify that it has to run on this layout on this machine. Then only the component will be deployed there and does a sorting individually. So this is how internally the component can working on two of the partitions. Then once the data has been sorted, I need to make it into a serial file. If it is a multi-file, directly we can connect it to the output file. Again, I need to make it into a serial file, so definitely it has to come to the deportation component. So this is how internally it works. Whenever you use a partition component, all the components will be running parallelly till you use any of the deportation component to make it a file or a flow serial. So is it clear?
Yeah.
You Ravali? Hello? Hello? Can you able to hear
Yeah,
it?
Venkat. Yeah, yeah.
Okay, okay, fine.
I think mine was connected a little.
Okay, okay. So is it clear so far whatever the parallelism concepts we have discussed?
Yeah.
Yeah.
Venkat, one question.
Yeah, Bhagresh.
Suppose we had done partitions, okay?
Okay.
So in first partition, my data is like 1, 3, oh, sorry, 5, 2, 1, okay. And in second partition, like 2, 6, 4.
Okay.
So it will do partitions individually, right?
No, you are giving this data within the partition, right? Already?
Sorry?
No, the data in the serial file you are taking like as 1, 2, 3, 4, 5, 6. So in the
Yeah,
partition 0, you are taking it as like 1, 3, 5, and in partition 1, you are
yeah,
taking 2, 4, 6, right?
yes, yes.
Okay. So then also what?
So, so you are applying sort, right?
Yeah,
For
yeah.
individually.
Yes.
So it will do individually, right? Sorting.
Yeah.
Then how it will be? I mean, complete sorted. Then I mean, first it will load means partition. Also, we have to make sure that right. Whatever the partition we have used, departition also it will hold like that. Is it the case?
So here I said deportation component. but we are the one who are designing the graphs, so we have to make sure which component to use a departition component. So I will
Yeah,
use
that's
merge component because already
okay.
within the partitions the data is sorted. So why will I use another one more component which is not meant for a sorting and the deportation?
Okay.
So if I use a merge component, obviously the file will be sorted order and it becomes a serial as well. So if you are not expecting a serial file, directly
Okay.
the flow will get connected to the output file. So a sorted data with multi-file system will be appeared.
Okay.
So you mean to say which deportation component to be used again to make it a serial sorted data?
Yeah.
Okay, okay.
Yes,
You
yes.
have to use merge component.
Okay.
Okay, and then we will step into a concept called flows. So for in any of the graphs, there should be a link maximum number of the components to get connected. Only the lookup files we don't be having any connection with any of the component. So out of this, all the components definitely there should be a link from one component to the other components. So the links are called as flows. We are calling it as. So how many types of the flows we have it? So we have four types of the flows: straight flow, fan out, fan in, and all to all. So these are the flows we have it. So what is meant by a straight flow? It's okay. So let's say the component A is running under 8-way multi-file system and component B is running under 8-way multi-file system. So internally these components are running. So as we see, this is like internal structure of the sort component, how does it runs. But if you see the graph whenever we are going to design, we will be designing like this. But the sort component will take care of sorting the data on the partitions. So similarly, here how the sort is running two-way, here the component A and B are running on the 8-way parallel, let's say. So I can create only one flow for this. So in such a case, what kind of the flow that get appeared between this component A and B? Okay, so it's a straight flow. So whenever both the components are connected on the same depth of the parallelism, then it's called as a straight flow. So here both the components are running on the 8-way parallel, then the flow that gets connected to between these two components is a straight flow. So easily you can say that depends on the depth of the parallelism. So if this is a lower depth or the higher depth, then the different kinds of the flow we will get it. But both the components are same depth, so the flow will be a straight flow. So this is clear. And fan out. Let's say this is running on the serial and this is running on the parallel. So we are getting the records from the file and distributing the records into the partitions. So once you use the partition component, the records that gets flowed into multiple data partitions. So in such a case, the flow appeared here is a fan outflow. The fan outflow looks like this. You're getting a record serial flow and you are making it into parallel flows. So the records will be
Venkat, can you repeat that again? Your voice was breaking.
okay. You're clear with the straight flow?
Hello, Venkat.
Yeah, Ravali. Are you clear with the straight flow or I need to start again with the straight one?
Your voice was breaking from the first, Venkat, from the time when you started the types of flows.
Okay, okay, fine.
Will you please explain again?
Yeah, sure, sure. Okay, coming to the straight flow. So when two of the components are running on the same depth of the parallelism, let's say here component is running on two-way and here also two-way, then the flow that gets connected is a straight flow. So when both the components are running on the same depth of the parallelism, then we can call it the flow that gets connected between these components is a straight flow. So whether it's a two-way MFS or 4 or 8 or 16, whatever it may be. So whatever the components that get connected are running on the same depth of the parallelism, then it can take it as a straight flow. Is it clear, Ravali?
Yeah.
Okay. And if we are making it as the component A as a serial and component B is running on two-way MFS file system, then the flow, whatever we are having it, will not be there. Okay, so the flow connected between these two components, you can see like within the flow, the data is coming into the serial way and you're distributing it into parallel way into two multiple different partitions. So this we can call it as fan out flow. Means the records are going out of the flows into multiple flows. So as the data is coming in the serial way, the records are distributing it into multiple data partitions. So that kind of the flow we call it as fan out flow. So which component will do this fan out flow? So when this automatically this flow gets connected will appear. This kind of the flow will appear whenever you connected the components. So after using which component the flows will appear like this. So whenever you are using a partition component, what is happening? The partition component is taking the serial data and distributing the records to different partitions. So the partition data will take the data from the file. So from the input file, the data will be taking it. After distributing the data to the different partitions. So the component B, let's take it a sort component, and this is a partition component. It has to work on different partitions. So the data coming from to the partition component is the serial file or the serial flow, and this component, the partition component, is making two different partitions. So any of the partition component you use, then after the flow will get connected is this one. It's a fan out flow. Is it clear?
Yeah.
You Ravali?
Yes, Venkat.
Okay. So we discussed
Yeah,
bridge
yes.
under the fan out flow. So fan out in the sense records are coming and distributing it to multiple partitions. So the figure looks like this. And coming to the deportation, I will show you how does it looks. The figure on the flow, quite opposite to that. Okay. So within the flow, on the flow, the diagram looks like this. So what kind of the components will produce? I'm saying this on the flow, it is a fan in flow. So what kind of the components will produce a fan in flow? So for whatever the concepts you know, which components will do this?
Mm, departition to other components, right?
Pardon?
I mean, departition to while giving departition, right?
Yes. Whenever you are using a deportation component, and once the deportation has been happened and the flow connected to this component will make it a fan in flow, because the deportation component gathers the records, all the records from the different partitions. So here the data is coming on the different partitions, data partitions, and we are making the flow into a serial flow. So here similar to this, see here the flow is serial flow and we are making it into parallel flow by distributing the records into multiple data partitions. Here we are reading the data from different multiple partitions, data partitions, and making the flow serial. So the deportation component, whenever you are using it, the flow that gets appeared by default is a fan in flow. And coming to the all to all, so this is how the diagrams looks like whenever the flow gets. So let's say the flow is like, by default whenever you are using a partition component, the flow will be like a fan out flow by default, but I can make it the flow as an all to all also by right click on the flow, select what is the type of the flow you want it. So you can make it as an all to all as well. So what will happen by making it as an all to all? It distributes the records to of all the partitions. It will make sure that it has to distribute the records to all the partitions. So sometimes whatever the components we have used, the partition components, are you making sure that it distributes all the records to all the partitions? No. Sometimes we have seen that there may be a chances that records are going to only one of the partitions. But if you're making it to the all-to-all flow, definitely the records will be flowing to all the partitions. So this is all like depends on the requirement we will be going at, but maximum cases we should avoid using an all-to-all flow. Can you tell me the reason why should we avoid using an all-to-all flow?
Mm, for example, if you have component like partition by expression,
Okay.
so based on that expression value, we can send it to the partition, right? So based on that condition, if there is no data for the second partition,
With
then we will send it
expression we
to,
cannot make it, right? We need
yeah,
to specifying the data should go to which partition.
okay,
So there itself within the partition, we are a partition component, we are deciding it to which data partition it has to send. So once the data is
yeah,
coming to the flow, then we are deciding. So that will not happen, right?
yeah, okay.
Okay. Any other reasons why we should not make the flow as an all to all? Okay, so by making the flow into as an all to all, here we are going to miss the records of the same case into two different partitions also. So if that is happening it, then no use of using these partition components and whatever the graph we are creating it, because we will get the incorrect results. So we are not expecting at any cost an incorrect results. We are expecting the performance at the same time accuracy should be there. So if we are missing the accuracy, definitely no one will accept that. So definitely a lot of chances are there to get the incorrect results by making it an all to all flow. So let's say like this is like a typical case. We are not following in real time, like making the flow as a three-way or a five-way multi-file system. In such a case, this definitely there will be 100% problem if we are using a three-way or a five-way, but this is a most typical case. The first one possibility is there, and the second one even the administrators will not accept, the architects will not accept by making the flows as a three-way or a five-way, because most of the times we will be going with the 2 to the power of n, the flow will be whether it's a 2, 4, 8 or 16 like that. But if it is a three-way five-way mfs file system, definitely there will be a problem, because it distributes the records to all the partitions, and then whatever the components we are using the next components to run on these data partitions, there will be a problem and we will get incorrect results again. Just to avoid that, so we will be using fan in, fan out and straight flow only. That is the best practice to do that. Avoid using an all to all flow. Is it clear, all the flows so far whatever we discussed?
Yeah,
Yeah,
Okay.
Venkat.
The next component, the next concept we have is the phases and checkpoints. So why do we require a phase within the graph? So you mean to say all the components within the graph has to run at the same time? Any try? Why do we require phases within the graph?
Yeah, we need to split the graph. Means, for example, if you are using lookup files or something, okay, that was created in first phase and that will be used in second phase. In these cases, we will go for phases, right?
The lookup files or which files?
Sorry?
The lookup files are the first component which gets loaded into the RAM. We don't require phases for the
Yeah.
lookup files.
No, no, no. Suppose Venkat, I have data in database. Okay.
Okay.
I'm creating file with that. Okay. That file will be used as a lookup file in my graph.
Okay, so it's an output file. Again, you are using it as a lookup.
Yeah.
Okay, yeah, that is one reason again. Yes. So whenever you are using an input file or an output file, making it as a lookup file. So input file means on the same phase we can use it as a lookup, but if you are using an output file, definitely the file has to create, then only you can do a lookups on that. So in such a case, definitely the phase has to be breaked. So on whatever the phase the file is getting created, we cannot do the lookup. So definitely if you have a requirement to use that file as a lookup file, wherever you have a requirement to use that as a lookup file, that component has to be in the next phase than the file which is getting created and using as a lookup file. So as Bagaza said, this is one reason why we have to make it as a phases. And another thing is, let's say I'm getting a file, external file, or and I need to process it, which has like header, body, and the trailer records. So I need to apply some of the validations on that. So do you say at any cost, whatever the file that is sending by the client will not be having any issues? So no one can say, because sometimes the file can process successfully and sometimes there may be a validation issues. So if there are a validation failures, I need to notify this message to the client, whoever it is sending the file. So this notification, when I need to send it, whenever there is a failure in any of the validations. So after processing of the graph and after completion of all the validations, only I can check the status whether it's a successful or any rejections are there. Then only I can notify to the client. Then in such a case, definitely the notification has to be in a separate phase where all the validations has to be completed, and then we have to check the status. Let's say I am creating n number of the reject files. So the status, whatever, if any of the one record is getting rejected, I need to notify it. So I can check the sizes of all these rejected files. If it is all or 0 byte files, then my status is successful, means none of the validations has been failed and I got a file get created, the output file. And if any of the file is rejected, any of the rejected file has a record, then some of my validation has been failed. So here itself, while rejecting a rejection itself, we will be having the rejected record, and what is the error for that have to make append for that, and we have to notify it to the client using a send mail component. There is a one component is called send mail. So using that we can drop an email to the client itself. So can I execute this send mail component on the same phase where my components are reading that file and processing it? What will happen, whether it's a successful or a failure, the notification will be sending to the client. Can we do this? Definitely no. So that is again one more reason why we definitely has to maintain the phases. Is it clear? Why do we require phase?
Yeah.
Okay. And whenever there is a different phases, so let's say I have used some 10 to 20 components, and after 5 components I have, for the sixth component I made it into the next phase, first phase. The first 5 components are in the zeroth phase and the next 5 components are in the first phase. So whenever the phase changes from one phase to the other phase, the phase number, then automatically a phase break will be appeared it. In between these phases, a phase break will appear and there will be a checkpoint at the phase break. So whenever there are two different phases where the first phase gets completed and the next phase will appear, the phase number. So in between these two phases, a phase break will be there. So and wherever there is a phase break, a checkpoint will get appeared. So why do we require a checkpoint is, so whenever the graph gets failed, let's say in my graph I have 5 different phases, means I have 4 checkpoints because I will be having 4 phase breaks. 0 to 1 is a one phase break and 1 to 2 is another phase break, 2 to 3 is another phase break and 3 to 4 is another phase break. And so like this 4 phase breaks will be there. And each of the phase break a checkpoint will be there. So let's say like the graph has been failed at the phase 3 and whenever I want to rerun the graph, at the current situation I want to run the graph from the point of the failure. So if I don't have the status where the graph has been failed, definitely it runs from the phase 0. I don't want that. To run these first 3 phases, my graph is taking half an hour time. And the next 3 more phases, it will take 15 to 20 minutes. So do I need to invest another half an hour to run from the starting? Again, we will get the same results. So if the checkpoint is like, will hold the status of the run, and whenever you are rerunning the failed graph, it will ask whether you want to run from the point of the failure or from the beginning. So if you are running the graph from the GDE, you will get an alert window asking for the graph has to run from the point of the failure or from the beginning of the graph. So you have to take a decision. It's from beginning or from the point of the failure. If you say from the point of the failure, then it whatever the information it has in the checkpoint will get utilized and run from the point where it got failed. And
Mhm.
even from the GDE, we can select from the beginning. So, but if you're running the graph from the back end, by default, it will start the graph from the point of the failure. There you will not be having any options or the alerts which can alert you or asking a request from you to select whether it has to run from the point of the failure or from the beginning. So this option will come only when you are running the graph from the GDE. But most of the times all the jobs will run from the back end. We are not going to trigger from the front end tools. It has to run from the backend command. So in such a case, if I want to run the graph from the beginning, because by default it runs from the point of the failure, I don't have any problem if my decision is from the point of the failure. But if my decision is to run from the beginning, how can we do this? You have any idea, Bhagirath? How can we do this?
Front end.
No, 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 from the back end. If you want to run the graph from the beginning.
No, Venkat, I don't have any.
From the GDE means yes, if there is any failure in the graph whenever we are running it, a window will get opened before restarting the graph. It will ask from the
Yes.
beginning you want to run or from the point of the failure. So depends on the scenario. We will take care whether it's from the beginning because both the options we are available. But from the
Yes.
back end, definitely by default, it will start from the point of the failure. So if my decision is from the point of the failure, even I don't have any issues. But if I want to run from the beginning, from the back end, whenever we are running it, then we have to make sure that a recovery file gets deleted. So whenever you are running the graph at the back end, a recovery file will get created. So from the front end, if you are selecting from the beginning it has to run automatically, the GDE will take care that deleting the recovery file and running from the starting. But from the back end this step will not be asked for you. So this is something we have to make sure we are doing it. If you're running from the beginning, definitely that recovery file has to be deleted and then rerun the graph. It will run from the point of the, it will run from the beginning. One second. Okay. So how we are going to delete that recovery file, we will be discussing it later session, but we have to make sure that we have to delete the recovery file if you are running from the backend and from the beginning of the graph. So is it clear what is a phase and a checkpoints? Why do we require it, the phases, and what cases we require the phases? Is it clear?
Uh, yeah, Venkat. And Venkat, one thing.
Yeah, yeah.
For example, what you said is that checkpoints will occur at when phase break is happened,
Yes.
right?
Yeah.
So if you want to, means I want to put a checkpoint at some component externally. So
No.
can we do that?
No, no, no. By default, it will get appear whenever there is a phase differences, like zeroth phase to first phase. So in between that, a phase break will appear it. But is there an
Okay.
option to delete that phase break? But you cannot set wherever you require it.
Okay.
Any other questions?
No, Venkat.
Okay, you Ravali, is it clear so far whatever we discussed in this session?
Yes, Venkat.
Okay, fine. Yeah. So the next session we will start it on Monday, Indian time, IST.
Okay, how many more sessions we have, Venkat? Roughly?
Uh, we will be having like functions. We will be the next concept. So the functions will take 2 days time, and then we will be stepping up into EME concept. And coming to the
Oh,
EME, we will be having like 3 to 4 sessions. So maybe by next week we can complete it.
okay.
Yeah. So next session for your time will be Sunday evening as usual timing.
Oh, sure.
Thank you. Thanks, Ravali and Bhagiraj.
Thank you.
Yeah, thanks.